Hello wonderful person, this is Anton, and today we're going to be discussing some incredible observations from distant galaxies, and specifically observations in regards to timescales. Because usually when we discuss the universe, the timescales are not something that's easy to imagine. We're talking about millions and usually even billions of years, which the human mind does not really comprehend very well. For example, the time it takes for a typical galaxy to collide with another is normally measured in millions of years, which means that normally we just see snapshots of these events and have to infer what's going to happen by basically finding additional examples. But today we're going to discuss something that does happen on human scales and involves some of the most powerful objects in the entire universe. Because here we have two examples of something changing in mere years, with one galaxy basically disappearing from view and the other galaxy waking up after 100 million years of slumber, with all of this happening in just the last 2 decades. And so here we're going to discuss these two very unique cases that challenge our understanding of how galaxies evolve. One galaxy disappeared completely in just 20 years, the other became a cosmic volcano, even though it was silent for such a long time. And well, let's start with the most recent discovery of that unusual disappearing galaxy. A galaxy that was accidentally discovered and then analyzed using the Subaru telescope and the Sloan Digital Sky Survey. And here we're looking at something referred to as J0218-0036. And well, it is pretty far away from us. A redshift of 1.8, which means that the light from this galaxy is approximately 10 billion years old, and the galaxy is about 16 billion light years away from us. But when it was originally discovered back in early 2000s, it was designated as an AGN, an active galactic nucleus. Essentially a galactic nucleus, or a central black hole, that's so active and so bright that it produces a lot of different emissions visible from billions of light years away from us. Which implied that the black hole in the center was actively feeding and creating a massive glowing accretion disk. So bright, as a matter of fact, that it was outshining the rest of the galaxy. But then this was accidentally captured again in 2023, and things here looked extremely differently. In just 23 years, they discovered that the galaxy has dimmed to approximately 1/20th of its previous brightness, or basically was only 5% as bright as before. But more importantly, the central engine, the central black hole, potentially dimmed by a factor of 50. And this happened in just 7 years. Although here it's actually important to understand that even though there was a 23-year difference, it's only 7 years because the light coming from this galaxy experiences a kind of a time dilation due to the redshift. In other words, technically we're seeing this galaxy move in slow motion. And honestly, when you kind of think about it, it kind of does sound a little bit mind-blowing. All of these distant objects super far away from us are technically moving in slow motion the farther away they are from us. But anyway, so essentially this galaxy almost completely disappeared. And until now, nobody knew this was even possible. It was always believed that these types of changes took possibly thousands or even hundreds of thousands of years and would never happen that quickly. Mostly because it was always assumed that black holes were sort of constant eaters and it would take quite a while for them to start shutting down and to lose their power. But here, J0218 shows us that a black hole can actually run out of fuel, which then shuts it down almost instantly, which is what scientists believe very likely happened here. And that's because by looking at this in different wavelengths, researchers ruled out dust clouds blocking the light and discovered that pretty much all wavelengths seem to have disappeared, confirming that the black hole seems to be losing its sustenance and is basically dimming in real time. And that's actually the first time ever this has been seen anywhere. It basically means that black holes can definitely completely stop and become almost invisible in mere years and not in thousands of years like scientists previously believed. But what's really intriguing in this case is the other discovery from just a few months ago that also shows us the opposite phenomenon from J1007 plus 3540. And so here we had one galaxy turning off, but another one was caught turning back on. And so here we have a giant radio galaxy that's located inside a massive galactic cluster. This one is a little bit closer, at just over 1 billion light years away from us, and it's essentially a different type of an active galactic nucleus that in this case produces two jets going in a different direction, that are not pointed at us. And normally this results in something like this. Basically, we have jets visible in radio light because many of these fast-moving particles interact with a lot of gas in between galaxies and then produce radio waves. And these galaxies usually form some of the biggest structures in the universe, with many of them spanning millions of light years, but only visible to most powerful radio telescopes. And well, that's sort of what you're seeing here as well. This is a gigantic radio galaxy and was found by using highly sensitive radio telescopes like LOFAR and GMRT. But the main discovery here was the fact that this galaxy was actually pretty quiet for a very long time. Yet, very recently, right at the heart of this galaxy, the jet emissions seem to have restarted. And surprisingly, after 100 million years of silence. But I guess the question is, how do scientists know? Well, this is based on the analysis of the radio image that shows us various features that took several 100 million years to form. First, they show us a compact, bright inner jet. This is a sign of the black hole's recent awakening. But surrounding this new activity is a cocoon of much older, faded plasma, which represent a kind of a ghostly leftover from previous eruptions of jets that very likely happened roughly 240 million years ago. And so here the lead researcher, Shobha Kumari, describes this galaxy as a kind of a cosmic volcano, mostly because of the way it seems to carve out structures stretching millions of light years, after which it goes dormant once again to reawaken in the future. And so here this galaxy is a perfect example of an episodic active galactic nucleus, a galaxy whose central engine turns on and turns off over cosmic timescales. And so when we compare these two discoveries, we essentially see two separate chapters of the same story. In the first galaxy, we see the process of shutting down because the gas supply rapidly declined, and in the second galaxy, we see a reawakening, showing us how black holes can sit dormant for millions of years before erupting again extremely suddenly. And while in many of these active galaxies, such as quasars and blazars, we sometimes see a lot of fluctuation and a lot of blinking, we have never seen an AGN literally turn off or turn on so dramatically, and especially in such a short time. And so here, by trying to understand how this happens and why the fuel supply seems to change so quickly, it will help astronomers understand how galaxies grow and eventually stop forming stars. But interestingly, there is also a bit of a difference between these galaxies, at least when it comes to the environment around them. And it's because the second galaxy, the one that just turned on, seems to be in the environment that's a little bit more hostile. Here, this galaxy cluster is filled with a lot of hot gas, referred to as intracluster medium. And this gas creates immense pressure that bends, squeezes, and distorts the jets as they try to push away from the black hole, which basically results in this somewhat bizarre shape. Which also tells us that the growth of a galaxy is a kind of a constant battle between the power of the central black hole that's producing the jets and the crushing pressure of the surrounding matter, which still ends up producing a giant radio galaxy whose jets expand, creating an object over 5 million light years in size. But here this also creates an unusual structure referred to as the double-double structure, or basically double-double jets. Here we have bright young jets emerging from the core, surrounded by much older, fainter jets that were created millions of years ago. Although obviously the question is, okay, so what exactly is happening near the black holes to create these extreme effects? Well, for this second galaxy, we know that despite being a node system, it also seems to show a high star formation rate that very likely triggered by some kind of a merger that provided a lot of fuel for both the stars and the central galaxy. In other words, this seems to be the result of some kind of a galactic collision inside this galactic cluster. And so all of this gas from the other galaxy merging with the gas from the original galaxy very likely creates many of these effects, with a lot of this gas then feeding the black hole. In contrast, for the dimming galaxy, it seems to have run out of gas completely and is basically shutting down, possibly for a very long time. Which essentially confirms that sometimes the universe is not very peaceful, and galactic evolution can be extremely violent and involve a series of episodes that happen extremely quickly. And so by studying these types of galaxies, we can learn a little bit more about how central black holes seem to work, how the eruptions transform the galaxy's surroundings, or possibly even shut down star activity. But based on these studies, more importantly, we now know that we can study all of this on human scales. because sometimes these changes only take a few years and can be physically observed and studied from right here on planet Earth. Which means that there's a very high chance we're going to be discovering more of these galaxies very soon. But importantly, one day this will also help us understand exactly what happened to the central black hole of the Milky Way galaxy and why it seems to have shut down and remained quiet for several million years. Now, based on previous research, we know that it was not always quiet, and it very likely was active at some point, possibly billions of years ago. And we also know that it was possibly powerful enough to strip actual atmospheres of most planets in the vicinity. As a matter of fact, if Earth existed back then, we don't even know if atmosphere would have survived. And so by studying these distant galaxies and by trying to understand the effects from central black holes, we might be able to understand how this affects various planets, and by extension how this affects the chances for extraterrestrial life. But in the end, this basically shows us that the universe is quite dynamic and quite unpredictable. And there are going to be so many more discoveries to come in the next few months. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.